Okay, so I'll do page 327, number 11. Okay, so first thing is we have to remember that in order to apply the zero product property later, we need it to equal 0. Currently it does not. So I'm going to subtract 2x from both sides, and then also add 10 to both sides. Okay, so that brings me to 6x squared plus 26x plus 8 equals 0. Okay, at this point I may notice that all three terms in this trinomial are divisible by 2. So I can factor that out. Okay, so can I factor this trinomial in parentheses even further? Okay, so 3x squared and plus 4. So I would need the two missing boxes to add to the middle term of 13x and multiply to the same product of 12x squared. So it turns out that 12x and 1x would fit both requirements. Okay, so now factoring by GCF, I have x plus 4, 3x plus 1. Okay, so my factored form, I still have this GCF of 2, but now I split up this trinomial into the product of two binomials, 3x plus 1 and x plus 4, and it still equals 0. Okay, so again, I can apply the zero product property. Either this is 0 or this is 0. The only way to get a multiplication answer of 0 is by multiplying by 0 at some point. Okay, so we get two answers. X could be negative a third, and x could also be negative 4. Okay, so for this same page, number 15, I won't solve completely, but I'll set it up. Okay, so you might think that this one's already factored, so it'll be really easy. But the problem is the other side is 9. It's not a 0. There's no such thing as the 9 product property. So we need to get this side equal to 0. Okay, so I'm going to distribute out the left side first. We got 8x squared plus 8x plus 7x plus 1. So combining these like terms, 8x squared plus 15x plus 1 equals 9. Okay, so now I can get this side equal to 0. Oh, sorry, this is a 7. 7 times 1 is 7. Okay, so now I can get this side equal to 0 by subtracting 9 from both sides. Okay, so from here you would attempt to factor it, and then if possible you would then use the zero product property. Okay, so moving on, now I'll do something from page 376, number 7. Okay, so here we're asked to solve by completing the square. So in class, the method I showed, I said set it equal to 0, then move the constant to the other side. Well, the way this problem is written, the constant's already on the other side, so we get to skip those two steps. And actually, the a value is 1, so we don't need to factor anything out either. So we get to go all the way to figuring out what fills in the blank. Okay, what do we add to both sides? So to figure that out, we skip ahead. Okay, we want to form a perfect square binomial. So the constant is always half of the b value. So here b is 12, so half of 12 is 6. And once you know the constant in the binomial, you square it, 6 times itself is positive 36. Okay, so we do want to make sure we add the same value to both sides. In this case, the 36 is simply 36. There's no other number in front multiplying it. So 36 on the left is 36 on the right. Okay, so that makes 41. Okay, so the perfect square binomial is already isolated. There's no coefficient, so we don't need to divide. We get to go straight to square rooting. On the left side, the square root and the squared cancel out, leaving the x plus 6 behind. On the right side, square root of 41 cannot be simplified, but we do need to add the plus or minus. Okay, and finally, to get the x by itself, subtract 6 from both sides. Okay, the negative 6 cannot be added or subtracted to our radical, so you keep them separated, but it goes in front of the plus or minus symbol. Okay, so there's the answer to number 7. And then for problem 9 on this same page, okay, so same thing. The constant is already on the other side, so I don't need to set it to 0 or move it, but I do need to factor out an a value this time. So the a value is 9, so I need to factor a 9 out of this left side. So 9x squared with the 9 taken out is just x squared now. 12x divided by 9. Okay, so 12 and 9 can both be divided by 3. So this becomes plus 4/3 x. Okay, and the right side is unaffected by the factoring, so it's still 32. Okay, so now we got to figure out what do we add to both sides so that we would be able to form a perfect square binomial. Okay, so thinking ahead, the factored out 9 will still be there. But then we know the constant is always half of the b value. This time b is 4/3. Okay, so what is half of 4/3? 4/3 divided by 2. Well, 2 is 2 over 1, and to divide by a fraction, you can multiply by the reciprocal. Okay, so half of 4/3 is 2/3. And once we know that, we can square this value to get the c value up here. So 2/3 squared means 2/3 times 2/3, which is 4/9. Okay, so we need to squeeze a plus 4/9 into the parentheses on the left-hand side. But this 4/9 is affected by the coefficient of 9. So this 9 distributed out would multiply the 4/9. So 9 times 4/9, 9 is 9 over 1. So this is actually adding 4 to the left side. 9 times 4/9 is 4. So on the right side, we also need to add 4. Okay, and then 32 plus 4 would be 36. Okay, so now we need to get the parentheses by itself. To get rid of this 9, we would divide both sides by 9. Now we can square root. So we would not want to square root on the previous step. Even though you might think that the square root of 9 is 3, it doesn't work like that. You can't square root the product of things separately. So just get the parentheses first before square rooting. Okay, and again, don't forget to plus or minus on this side. Okay, to get rid of this plus 2/3, we would subtract 2/3 from both sides. Okay, so in this case, when completing the square, if the things getting added or subtracted can be combined as like terms, you need to do so. You wouldn't leave it like this. Right, so one version of the answer is negative 2/3 plus 2. The other version is negative 2/3 minus 2. Okay, so in both cases, we would want to get a common denominator. 2 is 2 over 1, which is 6 over 3. So negative 2/3 plus 6/3 would be positive 4/3. And then negative 2/3 minus 6/3 or plus negative 6/3 would be negative 8/3.